A cotyledon is a significant part of the embryo within the seed of a plant, and is defined by the Oxford English Dictionary as the primary leaf in the embryo of the higher plants, the seed leaf. Upon germination, the cotyledon may become the embryonic first leaves of a seedling. The number of cotyledons present is one characteristic used by botanists to classify the flowering plants. Species with one cotyledon are called monocotyledonous. Plants with two embryonic leaves are termed dicotyledonous and placed in the class Magnoliopsida. In the case of dicot seedlings whose cotyledons are photosynthetic, the cotyledons are functionally similar to leaves. However, true leaves and cotyledons are developmentally distinct. Cotyledons are formed during embryogenesis, along with the root and shoot meristems, and are therefore present in the seed prior to germination. True leaves, however, are formed post-embryonically from the shoot apical meristem, which is responsible for generating subsequent aerial portions of the plant. The cotyledon of grasses and many other monocotyledons is a highly modified leaf composed of a scutellum and a coleoptile. The scutellum is a tissue within the seed that is specialized to absorb stored food from the adjacent endosperm. The coleoptile is a protective cap that covers the plumule. Gymnosperm seedlings also have cotyledons, and these are often variable in number, with from 2 to 24 cotyledons forming a whorl at the top of the hypocotyl surrounding the plumule. Within each species, there is often still some variation in cotyledon numbers, e.g. Monterey pine seedlings have 5 to 9, and Jeffrey pine 7 to 13, but other species are more fixed, with e.g. Mediterranean cypress always having just 2 cotyledons. The highest number reported is for big cone pinyon, with 24. The cotyledons may be ephemeral, lasting only days after emergence, or persistent, enduring at least a year on the plant. The cotyledons contain the stored food reserves of the seed. As these reserves are used up, the cotyledons may turn green and begin photosynthesis, or may wither as the first true leaves take over food production for the seedling. Epigeal versus hypogeal development. Cotyledons may be either epigeal, expanding on the germination of the seed, throwing off the seed shell, rising above the ground, and perhaps becoming photosynthetic, or hypogeal, not expanding, remaining below ground and not becoming photosynthetic. The latter is typically the case where the cotyledons act as a storage organ, as in many nuts and acorns. Hypogeal plants have significantly larger seeds than epigeal ones. They are also capable of surviving if the seedling is clipped off, as meristem buds remain underground. The trade-off is whether the plant should produce a large number of small seeds, or a smaller number of seeds which are more likely to survive. Related plants show a mixture of hypogeal and epigeal development, even within the same plant family. Groups which contain both hypogeal and epigeal species include, for example, the Araucariaceae family of southern hemisphere conifers, the Fabaceae, and the genus Lilium. The frequently garden-grown common bean, Phaseolus vulgaris, is epigeal, while the closely related runner bean, Phaseolus coccineus, is hypogeal. History. The term cotyledon was coined by Marcello Malpighi. John Ray was the first botanist to recognize that some plants have 2 and others only 1, and eventually the first to recognize the immense importance of this fact to systematics. In Methodus Plantarum, Theophrastus and Albertus Magnus may also have recognized the distinction between the dicotyledons and monocotyledons. Bibliography.